All right, let's take a look at data and statistics. So we're going to start this off with types of graphs. So we have 4 different types of graphs. First one, histogram. That's an H. Okay, so a histogram can be used to show frequencies, which is how often something occurs, or percentages. The distribution will be shown at different intervals. A histogram is a type of bar graph. So what you'll tend to see is like no separation, where a bar graph will tend to have separation between the different data points. Right? So you have something that looks something like this, right? Over here will be the frequency usually. Right? And then down here will be some sort of number like time, maybe, something that we're measuring. Okay, so that's histogram, right? Your main point here is to remember that it's a type of bar graph used to show frequencies. Okay, got that? That's histogram. What's next? Box plot. Okay. Sometimes box plot is the one people are the least familiar with. So we'll try to draw one of these. Right, so with a box plot, you'd have like this. And we got our box. That's why it's called a box plot. And over here, like this. Okay, we'll try to write all this in. It'll be kind of small, but I think you'll be able to see it. So a box plot will show you the distribution of data based on a 5-number summary. So there will be a minimum number, should be right here, okay? And that's an outlier, right? Something that doesn't show up that much. And on the other end will be a maximum number, right? Also an outlier in the other direction, okay? And then within this box right here, we'll have median, and we're going to be going over median in a minute as well, outside of box plot. But so we'll have the median right there, which will be the middle number in the data set. And then you'll have something called Q1 and Q3. Okay, Q1, Q3. And so Q1 represents the 25th percentile. Q3 represents 75th percentile. Okay, so those are the 5 things that we have within the box plot. Is the minimum, so I put Q1, or you could also call it first quartile, median, Q3 or third quartile, and max, right? And that's what makes up the box plot. So it's really just a distribution of data. Okay, next is dot plot. Dot plot is somewhat similar to histogram, which we looked at first, but it only works for small data sets. So it'll tend to be like, like 10 or less, right? And then they're just going to be measuring some outcome, like how many siblings do you have? And look something like that. So it can be bigger than 3, right? But it tends to be a pretty small sample size, right? That's one of the things you want to be familiar with, and also thinking similar to histogram, but smaller data set. And you could see why it's called the dot plot, right? All those dots. Okay, there's that one. And I think we got one more graph that we want to know, and that is scatterplot. Okay, so scatterplot, when scatterplot, you should be thinking line graph, right? So scatterplot's going to show you a trend line, right? So there'll be lots of little different data sets different numbers in here, right? And then we want to see a trend line going through it, right? We see something like that, okay? That's a scatter plot, okay? A trend line will show a precise relationship between the x-axis and the y-axis with many data points, and the trend line is just going through those data points, so just what we showed there. Okay, so there's our 4 type of graphs that we want to be familiar with, and we'll be asked about on the TEAS exam. Okay, and then next, mean, mode, and median. Okay, so you just want to be familiar with these. Mean just means average. Okay, so we're going to say that we have a data set of real simple data set, simple numbers to work with, 1, 2, 3, and 4. Okay, the simplest data set ever. Okay, and so if I need to find the mean, then I need to add up those 4 numbers and divide by 4 because there's 4 of them, right? So 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. So the mean would be 10 divided by 4, which equals 2.5. Okay, so that's mean. Mean is average. Mode is the most frequent number, right? So if there's a repeating number, like if this data set was instead of 1, 2, 3, 4 was 1, 2, 2, 4, right? There's 2 2's, the mode would be 2. Here there is no mode because they're all different numbers. And then finally, median. Okay, median is the middle number, right? And we referenced median with that box plot just a minute ago, right? Okay, so in this, right, when you have an even number, right? So there's 4 numbers here, so an even number in our data set, it's not clear what the middle number is, right? You sort of have 2 middle numbers here, 2 and 3. So when if you have an odd number, like if there were 5 numbers in the set, then you would just order them from lowest to highest, pick that middle number, which would be the 3rd number, and then you have your answer. That's the median. Okay, in this case, when the total is even in the data set, then you take the 2 middle numbers and divide them by 2. And so in this case, the median and the mean are the same, 2.5. Okay. This is stuff that you will occasionally end up using, right? So sometimes people want to know the median more than they want to know the mean or the average. All right, that's mean, median, and mode. Okay, could easily see a question on those. That should be pretty low-hanging fruit. Not complicated concept to understand, although it might have to stretch your memory a little bit back to when you first heard about mean, median, and mode, probably like middle school or something. Okay, and then we also have unimodal and bimodal. Okay, so if a graph has one clear peak in the data, it's unimodal. Okay, it does not matter where the peak shows up, right? There's one peak here. That means unimodal. Okay, if there are 2 peaks, bimodal, right? And it doesn't really matter what the size of the peaks are. It does not matter where they show up. This is how we differentiate unimodal and bimodal. Okay, and then a couple other things that can show up as questions, and I would say probably will. The left side and the right side of the distribution are the same. That's called symmetrical. Okay. Left and right are the same. We'll say same. That's symmetrical. If there are clearly more data points on one side of the graph than the other, then the graph is skewed. That's the term we use there. Uniform distribution looks like a straight line and has no peaks. Right? That would be called uniform. Sorry about the handwriting. So that would be uniform. And then finally, standard deviation is usually associated with a bell curve. So something that looks kind of like that. And that. There's our bell curve. The bell curve is symmetrical with its mean at the highest point and the majority of values falling close to the mean, right? So, you have most of our values are somewhere in here, right? Very close to the mean, which is this point right up here, the top of the graph. And again, kind of going back, so like if it's skewed, then we have a ton of data points over on the left and not very many over on the right. And then that changes how this graph looks. Okay, so that is everything that we need for data and statistics.